Hello and welcome to today's lesson on inertia. In today's lesson, we will understand how Newton's first law stems from the concept of inertia, which we will take time to define. Next, we'll consider the relationship between mass and inertia. Finally, we'll explore everyday examples of inertia, like passengers feeling pushed forward when a bus stops suddenly, and ice hockey players gliding on ice. So far, we have applied Newton's first law to understand the motion of everyday objects. You have learned how forces affect the movement and stillness of things around us. Building on this foundation, we can now delve deeper into the concept of inertia. Let's get started.
So, what is inertia?
Inertia is a concept that describes the tendency of objects to resist changes in their state of motion. This means that if an object is at rest, it prefers to stay at rest. Conversely, if an object is moving, it will prefer to continue moving in a straight line at a constant speed unless acted upon by an external force. This concept is encapsulated in Newton's first law of motion, which states, an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Let's apply these ideas to objects at rest. Imagine a heavy box sitting on the floor. To move it, you need to apply a force. The reason you need to apply a force is due to the box's inertia. It resists the change from being at rest to being in motion. And here's a critical point. The greater the mass of an object, the greater its inertia. This means a heavier object, like a large stone, will require more force to start moving compared to a lighter object, like a small pebble. Now let's consider inertia in the context of objects that are already in motion. An object in motion tends to stay in motion with the same speed and in the same direction, unless acted upon by an external force. This aspect of inertia can be observed in several everyday situations. Example 1, a bus ride. When you're on a bus that suddenly stops, you might feel like you're being pushed forward. This sensation is due to your body wanting to stay in motion, even though the bus has stopped. Your body resists the change in motion, deceleration, because of inertia. Our next example is ice hockey players. They glide effortlessly on the ice once they start moving. Their initial push sets them in motion, and because of inertia, they continue to move. The ice provides very little friction, so they don't slow down quickly. Their motion continues in a straight line until they encounter another force, such as a player's body or the wall of the rink. In today's lesson, we delved into the concept of inertia and how it is central to Newton's first law of motion. We defined inertia as the tendency of objects to resist changes in their state of motion, whether at rest or in uniform motion. We examined how inertia affects objects at rest, noting that greater mass results in greater inertia and thus requires more force to initiate movement. We also explored inertia in the context of objects in motion, demonstrating that they tend to remain in motion unless an external force acts upon them. By understanding inertia, we gained a deeper insight into Newton's first law and the behavior of objects when forces are applied or withdrawn. Watch the rest of the GCSE Physics course at Sophos Education.